Happy holidays. Hope everyone's keeping up with their homework over break. I know I'm about a day behind on mine, so let me get started. I want to put together some screencasts here. I'm going to start out with combination synthesis reactions. These are all types of reactions. You can fill this in on your packet if you've got it at home with you, but if you don't worry about it. Um, Types of reactions, what we're doing is we're looking for patterns uh, to recognize different types of reactions. Ultimately, what we want to do is we want to take a type of reaction and be able to predict what's being made. Okay, we want to take a look and recognize the pattern and say, hey, I know what's going to be made. Let's take a look at the first type, combination or synthesis. Combination comes from the word combine, which means put together. So that's what we're doing in a combination or synthesis reaction. Synthesis is simply a fancy word for combination, putting together. Our visual clue with any of this is that we will see one single product. We're going to make one thing. We're going to take a couple of things, put them together, and make one single thing. So a single product, that means we'll have one thing on the right-hand side of the equation. One item on the right-hand side of the arrow. That is our visual clue that we have a combination or synthesis reaction. So if we had a situation like this where we're taking hydrogen, reacting it with bromine, we need to be told that we're making a single product, that we have a combination reaction in order to be able to predict the products. What we can do is we take a look at hydrogen, we take a look at bromine, and we're going to put these together. So we're going to go off to our ion sheet, and we're going to look up hydrogen right here, and bromine over here. And we're going to put those together. I want to do a little sidebar out here. I've got hydrogen with its +1 and bromine with its -1. We're going back to those TEGIF rules for ionic formula writing. What we need to do is make sure this adds up to 0. I've got a +1 and a -1. That'll add up to 0. So that means I'm going to use one hydrogen and one bromine to make my hydrobromic acid or hydrogen bromide, HBr. Now, the week before we went on break, we saw that we were balancing equations. We know that this is not balanced. I've got two hydrogens over here because of this subscript here. I've got two bromines over here because of this subscript here. And I have one hydrogen over here, one bromine over here. It looks like we destroyed matter. That can't be. So what we're going to do is we're going to balance this off by putting a 2 out in front of here. And what this says is that I took a single hydrogen molecule and a single bromine molecule. And what happens is those molecules break apart, and I wind up with a hydrogen bromide molecule in one combination, but that leaves an extra hydrogen and an extra bromine flying around. So what happens is we wind up with that combination again. So we get these molecules breaking apart and rearranging to form two molecules of hydrogen bromide. To show that we formed two of them, we put this 2 out in front. Combinations can get a little more complicated. These are two elements coming together. That's probably the simplest case. With something like this, we've got ammonia and hydrochloric acid. So what happens is this comes together to form ammonium chloride. With more experience, you'll get to be able to put these together also. Again, another trickier one, calcium oxide reacting with silicon dioxide, we wind up with something called calcium silicate, SiO3. I should probably go back and check these for balancing. One nitrogen, 3 hydrogens, plus another one is 4 hydrogens. I got 4 over here. That's okay. That balanced one chlorine here, 1 chlorine there. It balanced out. Calcium oxide, 1 calcium, 3 oxygens, 1 silicon, 1 silicon. Again, notice I've got one product. I'm producing one product on this side here, one single product. Single product. Some of the more complicated ones do fall into a pattern. These two here, certainly with more experience you'll be able to do those. But these are some that you can do together, do right off the bat. We've got a nonmetal oxide. Nonmetal means that I've got something from the left of the periodic table, right of the periodic table, right of that stair-step line. And oxide combines with oxygen. So this is something combined with oxygen. That's what an oxide is. If I take a nonmetal oxide, such as sulfur trioxide, I've got sulfur, nonmetal, combined with oxygen, so sulfur trioxide, mix that with water, react that with water, I'm going to wind up with an acid. The acid that I'm going to wind up with is sulfuric acid, H2SO4. Again, I'm coming up with one product. Metal oxide, again, is something that is combined with oxygen. Here's my oxygen. This metal is calcium from the left-hand side of the table. If I combine a metal oxide with water, what I'm going to wind up with is a hydroxide. Hydroxide is a compound containing a compound containing the hydroxide group or hydroxide ion. That would be OH minus. So what I'm going to wind up with is calcium hydroxide as my product. Little sidebar here. Calcium, if we look that up on my list of common ions, calcium right here has got a positive 2. Hydroxide, further down here, hydroxide's got to be, there it is, OH minus. OH minus, again, based on those Tageff rules, this needs to add up to 0. Right now, positive 2 plus negative 1 does not add up to 0. So I throw another hydroxide down here, and I wind up with a formula of Ca parentheses OH2. Again, I should be checking these for balancing. I don't know that I checked this one. I've got 1 sulfur, 1 sulfur, 4 oxygens, 4 oxygens, 2 hydrogens, 2 hydrogens. This is balanced. This one here, 1 calcium, 1 calcium, 1, 2 oxygens. 2 times 1 gives me 2 oxygens, and then 2 hydrogens. 1 times 2 gives me 2 hydrogens. This is also balanced. Again, these are combination reactions. I'm winding up with a single product. I'm combining, I'm putting things together. Putting things together to come up with one single product. Let's do one more example. Just kind of to drive things home. Let's say I had sodium reacting with chlorine. Let's give me sodium chloride. Again, sodium's got a +1 charge. Chloride, as the ion, has a -1 charge. Do a little balancing here. I've got 2 chlorines over here, but only 1 over here. So I'm going to throw 2 out in front of that. Now I have 2 sodiums over here. Gives me 2 sodiums over there. Again, still just one product. So that is your combination reaction.